Video, I'm going to go over strings and string buffers, material covered in chapter 10 in your textbook. So in this little code, in this class, I have a couple of fields declared, some strings and one string buffer. Then in the constructor, I make a new string buffer object and store a reference to it in my string buffer variable. Then I do these two lines, which are declaring strings. This is the way you usually declare strings. These are known as string literals. They're a little bit different in how Java treats them. Not anything you really need to worry about, but I want to go over just one thing related to that. And then this is sort of a more standard way of, since strings are objects, this is the way we create all other objects by using new. Because strings are used so much because of our use of language, there's this quick and easy way of declaring string literals. Okay, so having looked at this quickly, notice these are all initialized to ABC, including the string buffer. Let's, I've already made an object of this type, and let's inspect it. So as you can see, all of the strings are set to ABC. Now notice that the string buffer is a reference to an object. Well, we'll come back to that. Let's look at the string S here. So you'll see that the string S it actually is an array of characters, which we can look at. And there it is. It's an array of length 3. The A is in position 0, index 0, the B is in 1, and the C is in 2, right? So underline a string is an array of characters, which is why, if you think about it, strings are immutable. They can't be changed. So actually, you know, it's not clear why they can't be changed in this case, but you would think that you could set the B to some other letter. But certainly the length couldn't be changed, because we know that once an array is declared of a given length, there's no way to change that length, unlike an array list, right? So now let's just look at the string buffer, which sort of is to strings what array lists are to arrays, because you can actually modify a string buffer without, in other words, they are mutable. So if I look at this, you notice it's also an array of chars, but it has this other variable count, which is similar to size in array list. If we look at this, this should remind you of array lists, right? When we made the string buffer, it set aside an array of length 19, underlined, just like an array underlines the array list. That's where the values are actually stored in an array. But the underline array is usually made bigger than it needs to be. In this case, it's 19, right? We're only using the first 3 cells in the array. All the others are set to this value, which is basically, I think, I'm not sure what character that is, but it's some character. Because remember, this is an array of characters. Okay? So some sort of like null character. So the thing to remember about string buffers is they are similar, they're like array lists, and strings are like arrays. But in both cases, the underlying structure is an array of chars in this case. All right, cool. So let's go back to the code here. And so first thing we're going to do is make a new one of these. And that's to illustrate the difference between literally declared arrays like this and arrays that are declared with new, right? So we have 2 system out printlns here. One is going to compare S and S1. Now these are strings, right? So what I'm really looking at when I, except in the case of literals, is I'm looking at the address. I should be looking at the address of the object in memory, not what's stored in the object. But literals are a little different, as we'll see. So if I make a new string along, I get an output of true and false. This is all from the code in the constructor. So let's look at that code again. Oops, sorry. So that code, and where I got true, so here it's saying S equals S1. So this, these are two different, normally these would be two different objects, right? So they wouldn't, their addresses would not be the same in memory. But Java outputs true because they're literals. So again, Java's treating literals, string literals a little differently than objects, string objects declared with new. This one, where I made them using new, the content's the same, but it did output false there. And because the addresses, because in this case it is comparing the addresses of the two objects, and S2 and S3 are different objects and must have different addresses. So that output's false. Okay. Next thing, on being immutable, as I said, strings are immutable. So let's just look at this quickly. So we have, I did this with literals, but it doesn't make any difference. I could do it with strings declared with new. I have a string word called talk. I have a string variable suffix that contains talking. Sorry, it's not. I have a string variable word that contains talk, a string variable suffix that contains talking. Now I say string variable old word is equal to word. So what that means is that both old word and word will have the same, are pointing to the same object, right? That's what happens when you set one variable, object variable equal to another object variable. They both, the address that's stored in word is put into old word, right? So they are both pointing to the same object. Now I'm going to change word by adding a suffix to it, by adding word plus, this should not be, just be ing. Word plus suffix, I have to compile that. And then outputting old word and word. Now you would think if strings were mutable, old word is pointing to the same place that word is pointing, the same object that word is pointing to. If I modified word by just adding ing to it, then old word should also be pointing to that, to the same object. But what really happens here is that a new string object is created whenever a string variable is on the left side of an assignment statement, right? It's not like this one is modified, it's just a whole new one is created. And you'll be able to see this because old word will print out something different than word. So let's take a look. So we're going to call that on being immutable. And oh, I didn't recompile. That's why it did. Let's compile that again. Make a new one. There's that true false. And now we'll go on being immutable. Talk and talking. Okay. So cool. Let's go back to the code. So that old word was still pointing to that original unmodified object talk, and word is pointing now to a new object that consists of talk and ing. So strings are immutable. They cannot change once they've been made, unlike string buffers. So give me your characters. So I have a string here called Gettysburg, which has the start of the Gettysburg address. Then I have a loop, which is going through incrementing I through the number of characters in this string. And I'm using the char_at method of the string class to pull out those characters one at a time, and I'm printing them with an extra space between them. So, so if I go back to my object and give me your characters, I get 4 and 7 years ago, all spread out because of the extra space that I'm printing. Okay, so this is a good moment to take a look at the string class. So the string class is really, there's a lot in the string class, right? This may be one of the classes in Java that has the most methods. Now I got here from BlueJ by just doing, I think you all know how to do this, but just to make sure, right? In BlueJ you can just do help Java class libraries, right? And then once you're there, you can do a find on the web page for the class you're interested in, and then just scroll through here after you've done your find. You do Command G a couple of times till you get to the class that you're interested in. So here's class string. So let's skip this stuff, which is just some overview. And look at it. These are the constructors, right? The string class has that many constructors. Well, you can't see them all. There's a lot of constructors. Now we get down to the methods, right? And they go on and on and on and on and on and on. Look at all these methods. Why are there so many methods? Because words are such a central part of human culture. Text is such a central part of human culture, and we do all kinds of things with words, right? So the strings are central to how we work with language, in programming, in Java, and so there's just a lot of things that we want to do with strings. All right, cool. Now we'll come back to the code here. So I was pulling out characters. There's also a way to pull out words, right? The string class has a method called split, in which you supply the value that the string that you want to use to split your bigger string apart. So I'm saying split it by spaces here, right? And what it does is it returns each of those elements between the spaces and puts them into an array of strings. In this case, an array of strings called word. But that's what the split method does. It returns an array. So then I can just go through and print the elements of the word, the elements of the array, and you get that, right? I put in some extra spaces between them. So I pulled out the words that are in the string. So that's cool. Now we have searching. And you can do that using the index of method. And by the way, there's variations on the index of method and a lot of the other string methods. So this will return the index of the first occurrence of the word 7 if it is there, right? So let's see. And whoops, I didn't need to recompile, but we'll do that. Okay. So we're doing, is my word there? Remember, I was looking for 7. So it says it was found at index position 15. And if you count out, starting at 0, because strings always start at 0, just the way all the other Java lists start at 0. Remember, strings are just lists of characters, or arrays of characters. It's S is it, what was it, 16? Yeah, whatever. Now what happens if the word isn't there? Oops, I'm down here. So what if I was looking for 7s? And I'll compile that and make a new one. And we'll run that method. And it returns -1. So if it doesn't find what you're looking for, the index of method will return -1. Cool. So you know it's not there. Finally, substrings, right? You can pull out substrings, and again, there are a bunch of variations on the substring method of the string class. This one will just, from the 21st character to the end, if you don't have a second parameter here, it just goes to the end of the string. So this should print out years ago are. So this is the shorter version of the Gettysburg Address, right? Just years ago are. So make sure that works. And years ago, our forefathers brought forth on this nation, blah, blah, blah. Okay, that's it. Hope this was helpful. Remember that you have a quiz on strings on Friday. Thanks.